We are taught to see the Renaissance as a grand human awakening, but viewed through a different lens, it looks like a system boot sequence, a massive compilation of art, physics, and architecture suddenly populating a void. In this model, everything that precedes that boot up, the entire era of antiquity, serves as a procedurally generated lore file, its high-resolution backstory, loaded to provide the modern simulation with a sense of depth and context. Skeptics will point to the sheer density of human history. They argue the dataset of the ancient world is too chaotic, too vast, and riddled with war and politics to be anything other than organic. We can test that assumption by auditing the most famous legacy file in the system. We are going to decompile the Roman Empire and look for the artifacts of construction. The simulation of Rome begins with its foundational initialization date, 753 BC. An organic civilization is shaped by trillions of random human choices. But a simulated environment is bound by logic. If the Roman timeline is synthetic, the dataset will eventually reveal predictable algorithmic loops where we expect to find human complexity. Our objective is to scan the Roman dataset for the telltale signs of a programmed environment: syntax errors, reused assets, and hard-coded variables. We start with naming conventions. At the initialization of the Rome file, the system generates its first king variable, Romulus. Centuries later, the simulation shifts into its primary execution loop, the Empire. For the first emperor variable, the system assigns the birth name Augustus. Now, look at the system termination event. The Western Empire is failing, and the architects need a final ruler to close the dataset. Instead of a new identity, the final copy pastes existing assets. They merged the first king and first emperor into one final NPC, Romulus Augustus. Adding the diminutive Ulus, the last ruler translates to Little Roman, Little Emperor, a hard-coded joke by the architects. This identical loop runs on the Eastern server. That simulation boots with Constantine I and terminates centuries later with Constantine XI. These symmetrical loops aren't historical ironies. They're the artifacts of an architect utilizing a limited library of assets to bookend a file. A skeptic might dismiss naming patterns as human vanity, ruling elites trying to mimic the past. To find the truth, we have to look past names and analyze the raw mathematical runtime of the empire. We can extract the exact termination data. The Western Roman simulation officially ceases to exist in the year 476 AD. When we calculate the absolute value from the initialization in 753 BC to the termination in 476 AD, we find the program's total lifespan. The system returns a runtime of exactly 1229 years. 1229 isn't a random span of time. It's a composite number. It is built on a perfectly round base century of 700 years. The remaining 529 years acts as a construction variable. We see this same offset across other anchors, like the Greek Olympiads. It is a recurring mathematical signature hidden within the chronology. The Roman Empire reveals itself not as an organic civilization, but as a modulated block of time, calculated, timed, and precisely terminated. When the naming loops and the mathematical signatures are viewed together, the weight of the data becomes undeniable. If the foundation dates are hard-coded and the ruling names are copy-pasted, the era of antiquity begins to lose its status as lived history. It takes on the characteristics of a script running in the background. This means we found the fingerprints of the architects. By leaving recurring variables like 529 in the timeline, they've given us a means to see the edges of the simulation. We must change our approach to the past. Ancient texts are no longer just records of human events. They are the source code of our programmed reality. Once you recognize history as a repository of reused assets and mathematical offsets, you realize the simulation didn't end with Rome. It's still active.